permanent magnets and electromagnets. Substances which at room temperature retain their ferromagnetic property for a long period of time are called permanent magnets. An efficient way to make a permanent magnet is to place a ferromagnetic rod in a solenoid and pass a current. The magnetic field of the solenoid magnetizes the rod. The hysteresis curve allows us to select suitable materials for permanent magnets. The material should have high retentivity so that the magnet is strong, and high coercivity so that the magnetization is not erased by stray magnetic fields, temperature fluctuations, or minor mechanical damage. Electromagnets. An electromagnet is a type of magnet whose magnetic field is produced by the flow of electric current. The magnetic field disappears when the current ceases. Core of electromagnets are made of ferromagnetic materials which have high permeability and low retentivity. Soft iron is a suitable material for electromagnets. In certain applications, the material goes through an AC cycle of magnetization for a long period. This is the case in transformer cores and telephone diaphragms. Note: the hysteresis curve of such materials must be narrow. The energy dissipated and the heating will consequently be small. The material must have a high resistivity to lower eddy current losses. Example: a domain in ferromagnetic iron is in the form of a cube of side length 1 micrometer. Estimate the number of iron atoms in the domain and the maximum possible dipole moment and magnetization of the domain. The molecular mass of iron is 55 gram per mole and its density is 7.9 gram per centimeter cube. Assume that each iron atom has a dipole moment of 9.27 into 10 to the power minus 24 ampere meter square. Solution: the volume of the cubic domain is V equals to 10 to the power minus 6 meter whole cube, that is equal to 10 to the power minus 18 meter cube, that is 10 to the power minus 12 centimeter cube. Its mass is volume into density, that is 7.9 into 10 to the power minus 12 gram. It is given that Avogadro number 6.023 into 10 to the power 23 number of iron atoms have a mass of 55 gram. Hence, the number of atoms in the domain is N equals 7.9 into 10 to the power minus 12 into 6.023 into 10 to the power 23 divided by 55, that is equal to 8.65 into 10 to the power 10 atoms. The maximum possible dipole moment is achieved for the unrealistic case when all the atomic moments are perfectly aligned. Thus, its value is 8 into 10 to the power minus 13 ampere meter square. The consequent magnetization is equal to M max divided by domain volume, which comes out to be equal to 8 into 10 to the power 5 ampere into meter inverse. Concepts. Number 1. What are ferromagnetic substances? Solution. Ferromagnetic substances are those which gets strongly magnetized when placed in an external magnetic field. Question 2. What are called domains in a ferromagnetic material? Solution. The small part of volume in which the magnetic moments are aligned in the same direction are called domains.